All right, so let's say that our goal is to take this $half, whose measurements are a radius of 1.5 centimeters plus or minus 0.05 centimeters, and a height of 0.2 centimeters plus or minus 0.05 centimeters. We want to take those dimensions and find a best estimate of the volume. Of the $half, as well as an estimate of the uncertainty in the volume. All right, so one thing you may need to know for this is formula for volume according to geometry. So we always have that the volume of a cylinder will be given by the area times the height, which in this case would be pi r squared times the height. So what you want to do is plug in the best estimates first. That's the first number here. These are the best estimates. And just get a best estimate of the volume. But then you could find a largest value for the volume and a smallest value for the volume, and then subtract to get the uncertainty in the volume. When we're finding the best estimate of the volume, we just want to plug in the best estimate of the radius and the best estimate of the height. Simple as that. So we'll do pi times 1.5 squared times 0.2. I'm getting 1.41 cubic centimeters, but question is how many significant digits should I give in my final result? Like, is 1.41 enough or too much? So in order to answer that, we have to use the rules for significant figures when we're multiplying. And the way it works is you have to figure out how many sig figs are in each of the numbers that went into the calculation. All right, so 1.50 has 3 sig figs. All right, because they didn't have to put that 0 down. Like, I put that 0 down on purpose because I thought the quarter's radius was closer to a 0 than a 2 or an 8 or whatever. So it's got 3 sig figs. How many sig figs does 0.20 have, though? 2 sig figs. The leading 0 is not significant. They never are, but the trailing 0 is significant because it has decimal point expressed. So what that does is it's actually supposed to limit our final answer number of sig figs to whatever the smallest number of sig figs was in the numbers that went into the calculation. So this one has the least number of sig figs. So that 2 sig figs will limit our final answer to 2 sig figs. So I actually want to make it just 1.4 and just leave it like that, actually. Okay, so give 2 sig figs in the final answer. All right, now we just want to go a little bit farther, though. and find the uncertainty in our volume. Sometimes people mistakenly think it's just going to be 0.05 because that's what it was originally in our measurements, but that's not the case. We'll show that the uncertainty in the volume is going to be very different from that. So how do we find it? Well, we can find the largest estimate of the volume and the smallest. How would you do that? Well, to do it, I would do pi times 1.5. Yeah, for the largest, we'll add the uncertainty to the radius and add the uncertainty to the height, and we get, looks like 1.8 or 1.9 cubic centimeters. Okay, and then we'll subtract for the smallest. And that makes 0.9 or 1.0. It just gives us a sense of like how large the final result could be or how small. So in the middle we put the 1.4, the best estimate. And then our confidence interval goes from 1.0 up to 1.9. The uncertainty will be the largest minus the best. Is one way to find it. So it's 0.5, it looks like, cubic centimeters, 0.4, 0.5, around there. So finally, when we give the answer, you want to say V plus or minus the uncertainty in V. It would be 1.4 cubic centimeters plus or minus 0.5 cubic centimeters.